So basically, the valuation across individuals is what we call demand curve, right? Demand curve traces out for each individual how much they are willing to pay to purchase a particular goods. The obstacle for applying review preference approach by looking at the market price for environmental goods would be that they are non-market goods. So it's a similar issue for all the problems we encountered in the first part of the course. There are no markets for environmental goods. There's no market for clean air. There's no market for panda production. So we have to use indirect approach, design some other approach for these type of review preference valuation. So indirect measures we are employing include travel cost, hedonic pricing, avoidance, behavior avoidance, expenditures. We're trying to go through them one by one. So again, the idea of review preference is that when both bundle A and bundle B are affordable, the review preference is how do your choice tell us about your preference? How do your choices reveal your preferences? If bundle A and bundle B are both affordable, bundle A is chosen, it is reviewed preferred to bundle B. So travel cost methods infer values of recreational resources by determining how much visitors spent getting to a site and use this information to estimate the demand curve for that site. So to explain this intuitively, the idea is that if you're willing to visit a national park driving thousands of miles, then your willingness to pay for this national park must be higher than your travel cost, must be higher than all the gasolines you used on the roads just to get to that area. So the travel cost methods have been used to value national parks, recreational fish beaches. So the amount is basically trying to calculate how many people are willing to visit these places and how much these people spend traveling to these places. The motivation, so this is a very practical method. It's being used a lot, especially in the problem of recreational sites, beaches, protected mountainous areas, something like that. And this approach is actually created or invented out of a serious question, which is the history went like after World War II, the U.S. National Park Service sent letters to economists asking them whether or not they know how much the national parks are worth to the U.S. citizens. And that pretty much determines how much we need to allocate in terms of physical resources to this area. And the problem is that it's not a marketed goods. If it's a Disneyland, then we're able to judge how much people value Disneyland, looking at the entrance fee you're willing to pay, how many people are willing to pay this entrance fee. But since we're talking about national parks and they're free, we won't be able to directly look at its market price because there's no market for that. So the travel cost method was actually invented by Hotelling. So you remember Hotelling? It was the guy who predicted about the growth trend of oil prices, or the Hotelling rule told you about basically how would you use non-renewable resources, what's the extraction path of non-renewable resources. That's the other work of Hotelling. So this is another work of Hotelling. It's trying to value national parks. So this was the original letter he wrote to the government guys. Remember, basically, it's U.S. National Park Service wrote to economists soliciting methods for park valuation. Hotelling wrote the letter that this was the original letter. The idea was that for a pretty remote beach, I'm not sure if you have been to this beach. I've been to this beach. For a specific beach, if you wanted to know how much Hong Kong people live near these areas, enjoy this beach, what he wanted to do, since this beach was free, it was open to the general public, you can't take a look at its entrance fee. What you were doing is you look at something that pretty much acts as an entrance fee to people, which was the travel cost. So suppose in order to reach to the beach, you need first go to Cyclone, take a bus, walk for 3 hours. And all you need to do is add up the travel cost to get to this beach. The thing that the thing that lies between you and an iPad is the market price of the iPad. The thing that lies between you and the beach is the cost you need to spend, both in terms of time cost and in terms of fare cost, in terms of monetary cost, in order to get there. It's a similar idea. You use the travel cost as a type of cost. So suppose your opportunity cost of time is 80 Hong Kong dollar per hour. You spend, like the round trip, you spend 6 hours on the trip, 4 hours for walking, 2 hours for 2 hours on the bus, plus $50 on the bus. You in general you pay for 530 Hong Kong dollar per trip just to get to the beach on average. I think here you need to walk for 2 hours. That would explain the fall here. So the round trip costs you 530 Hong Kong dollar. The fact that you're willing to pay for this, you're willing to spend all the time and the resources and money just to get to the beach means that the value that the beach brings to you is higher than 530 Hong Kong dollar. So the way we do this is that suppose there are 4,000 people who visit this beach each year, and each of them basically pays at least 530 on their trip. The total travel cost would be 2 million per year, and the total valuation of these people, the valuation we can infer from these people, suppose 4,000 is monthly visit, the total value we can infer from these people are at least or at most 2.12 million. So would 2.12 million be an upper bound or a lower bound for the kind of joint valuation? So will the actual valuation of these people be higher or lower than $2.12 million? You can have different reasons. It's actually an open question.
If we consider cost rate,
yes, so
cost is fixed.
The value must be higher. It must be at least 2.12 million. Yes, obviously the reviewed preference approach is going to give you a lower bound. Tells you that your willingness to pay for trip is at least 530. It could be 600, could be 700. You're willing to do this means that it's higher than 530. So it's going to be a lower bound for that reason. So it's a lower bound because anyone finds it optimal to spend time, they must receive at least the travel cost. It could be more. So this is a simplified example. The simplification comes from different sources. First, we assume everyone has the same travel cost, right? So an improvement of this approach is that we might be able to collect data on travel costs for different kinds of visitors. Some visitors who live further away incur higher travel costs. Some people who live closer incur lower travel costs. And people who live closer are more likely to visit this area, this beach, more frequently. That's exactly the idea of demand curve, right? When the travel cost is higher, you're less likely to visit the site. So a more generalized approach applying travel costs is to collect information on visits, calculate round trip costs for each zone. Sometimes you just divide areas around the beach into different zones. You're able to collect number of visits originating from each zone. You calculate the round trip cost. You are able to get a table like this. When the travel cost is higher, here the price is more like travel cost. When the travel cost is higher, the quantity reduces. That's the exact idea about a demand curve, like downward sloping demand curve. You are able to run a regression, get an idea of what the shape of these curves look like, right? And once you have the curve, you are able to basically figure out the consumer surplus, right? So here the valuation is pretty much about the summation of consumer surplus. So you're able to figure out demand curve and all the areas beneath the demand curve tells you about the aggregation of consumer surplus. Right? Any questions? So, and you can add more variables to the regression if you're interested in how different attributes, different individual characteristics determine the visitor rate, determine the willingness to pay. You look at willingness to pay across different subpopulations. There are concerns about travel cost methods. So before going into all this, can you raise your own concerns about travel cost method? How much do you think the travel cost method might be missing some important points? So what would be the limitations of travel cost method? How would make it hard to apply or hard to explain what it's supposed to be explained?
Like the health condition and the ability to speak different languages, like foreign languages.
Why would that matter? Sorry, I'm just trying to ask you how well the travel cost method is to approach to help you understand about evaluation. Of course, here in the regressions, you can put in different individual characteristics. If this guy is able to speak the foreign language, he's more likely to visit the foreign countries. Sure. So one criticism you could have for travel cost method is that you have to see people visiting these places, right? So it only applies for use value. So if we're talking about option value or non-use value, you don't see people visiting panda sites, but they could still be valuing the existence of panda. The thought that there are some pandas happily living in some places make them happy. If that's the source of valuation, it's not going to be captured by travel cost method because these people never visit the panda site. That's one thing. The other thing, at least the other thing, when I try to think about this cycle example, would be how much you actually enjoy your trip to the beach. Right? Of course, you probably don't enjoy your bus ride that much, but walking in the mountains, your trip between the bus station and the beach in the mountain, it's in hiking exercises and hiking activities. You might actually have value for hiking itself. You might be able to enjoy the mountain scene, enjoy the clear area, any mountain area. You are able to observe the scenery of the beach throughout the road, throughout the path, and you have value for that other than the beach. It's hard to separate out your potential enjoyment, your potential utility derived during the trip. Like, you're treating the whole trip as a cost, but it might not be a cost. It might not be a full cost. Of course, you're paying your time, you're paying the bus fee, but your time is used not just for the enjoyment of the beach at the final destination. Your time is used for enjoy the exercise, enjoy the mountain sceneries, something along those lines. There are other points. So what are the right origin zones? So how far away do we need to draw these origin zones to apply this more generalized travel cost method? What is the right functional form? What is opportunity cost of time measured? So how would you calculate the opportunity cost of time? So how much would 1 hour worth to you? So hourly wage rates is one idea. But some people would say that you are earning wage for only 8 hours of the day. You have 24 hours per day. You're sleeping 8 hours per day. You have 16 hours disposable time. And it's hard to say that your leisure time either was zero or was your hourly wage. Right? Sometimes people are using 1/3 or 1/2 of the hourly wage rate as opportunity cost of time. But there could be a reviewed preference approach as well. So one idea for people to review their opportunity cost of time, especially during travel, is to observe their choices of going through a route that is more expensive but fast versus a route that takes more time but is cheaper. So imagine that in Hong Kong there are 3 tunnels bringing you from the islands to our area, and some tunnels are charging a higher fee than other tunnels. Then the fact that you are going through suppose one tunnel charges $5 more than another one, but it saves you 1 hour. It means that your willingness to pay for time, the opportunity cost of time during the trip is at least $50 per hour. So that's a method used pretty commonly to infer in a reviewed preference way about the opportunity cost of time, especially during travel, because you don't want to compare apples to pears. Here we're talking about opportunity cost of travel time. It's best to put this under a travel setting. So how much are you willing to pay to save an hour during your traveling. A related issue is how do we cheat multi-purpose trips? That's another issue, right? If you go to the beach, if you go from your home to the beach and then you spend some hours in the seafood restaurants, then going back home, it's hard to say. It's hard to know the travel cost across different purposes, right? You can say we just divide this. Maybe 80% of the reason of this trip is motivation of the trip is the beach, 20% is for the restaurants. But unless these people is going to tell you about this, otherwise it's impossible for you to know, judging from their behavior. And we know that another issue with travel cost method is that you're unable to put values on different site attributes. So if you're interested in evaluation of the whole site, you can use the travel cost method. But if you're interested in specific site attributes, such as the clean air, the clean water, the quality of sand, it's relatively hard to do so. But it's not impossible, because what you can do is suppose you can find two beaches. One beach has high quality sand, the other beach doesn't have high quality sand. And the other attributes are comparable, and then you can use travel cost methods to get a valuation of these two sites separately and construct a difference. Use the gap in your valuation between these two beaches as the valuation for high quality sands. But in real life, sometimes it's hard to find comparable beaches. So that's one issue. The reason that it matters is because when we're talking about ExxonMobil oil spill compensation, so the oil spill is going to destroy part of the site, right? It destroys the water. It doesn't do a lot of. It might affect the biodiversity of the ocean, but it has limited effects on air quality. That's limited effects on the ground, on the trees, on the scenery. So, if we're using travel cost methods to study how valuable people enjoy within this area, we might have a trouble kind of isolating out the negatively affected attributes and the attributes that remain intact after the oil spill. All right. Any questions? Comments? So other than the travel cost method, and question?
Sorry, I missed one thing. The origin zones, you mean by the place where people come from, go to the place of visit?
Yes,
right?
Yes, the origin zone is you draw rings around a particular site, and you try to collect. You're kind of assuming that people who come from the same ring have similar travel costs, and you count the number of people whose trips originate from each originating one. That's the idea. But you can just cheat. This is basically trying to cheat distance of travel cost in a discrete sense. You can do this continuously. You can just collect everyone's home address and calculate the distances, and that's a continuous method. So the zone, the origin zone doesn't matter as much. It's not a key issue here.
Okay, thanks.
I think we are at the time of a break, so let's have a 70 minutes break, maybe see you in 9:05. Okay, let's come back for the final session of this class. A different approach is called what we call hedonic pricing. Hedonic pricing is basically, suppose we could observe the price of something, and the price of this particular goods is dependent on some marketed attributes and some non-marketed attributes. How would we load the impacts of these non-marketed attributes on explaining something's prices? Typically, the goods we were talking about is housing. The housing price is used very extensively in understanding some features of neighborhoods. So imagine when you're making the decision of buying a house, some choices about the quality of the house itself. Other choices rely on where the location of the house and all the other attributes associated with location, right? And typically, when we're talking about hedonic approach of using housing price, you can use hedonic price. You can look at other prices. Suppose you're interested in how people value fuel economy when buying cars. When buying a car, you look at how differences in fuel economy when differences in car prices. So in the housing example, so what you care about buying a house, what makes the specific house valuable, some features attached to the house itself, the size, number of bedroom, number of bathroom, how many kitchens, how many whatever. How old this building is. Neighborhood characteristics, right? The school zone is an important one. The crime rates, how safe the neighborhoods are. Accessible characteristics, whether or not it's close to subway stations, that sort of thing. Environmental characteristics such as air pollution, water quality, proximity to landfills. So the task for us is how do we isolate the part of housing attributes, the part of housing price attributable to environmental quality. Conditional on all the other factors that would affect housing price. Right? So the hedonic property value is basically the hedonic approach relies pretty much on trying to control for all the other factors, trying to hold all the other factors constant and isolate the variation pretty much. The variation in housing price is pretty much only driven by the outcome of interest you're interested in. The explanatory variable of interest you're interested in. So suppose we want to estimate the emphatic benefit of the CVU in HKUSD. So suppose the houses are for sale. The ideal thought experiment is we just find two apartments, one with a view to the sea and one without a view to the sea. The other attributes should be the same, like they're in the same block. They have same number of rooms, same number of bathrooms, same size. The only difference is one apartment has a view to the sea, the other apartment doesn't have a view to the sea. In a similar location, same height. So suppose we're able to find these two apartments and we know the prices of these two apartments. The gap in their price gap should tell us about the valuation, the individual household's valuation about proximity to the sea, about the sea view. Right? Suppose for each house, people are willing to pay for $10,000 for the sea view, and there are 1,000 houses around with sea view. The kind of valuation of sea view is something like 10 times 2,000. Like. So as I said, the key empirical task, the empirical question is how do we control for all the other factors as much as possible, right? I'm trying to go through a paper. So this is a paper on environmental health risk